thank you very much. Fortunately, we're doing this during lunch, so people will probably come in with food. That's awesome. Enjoy it. But anyway, so static analysis security testing for dummies and you. The first thing is I have way too much content here. I started to realize I was putting it together, so I trimmed it down to 50 slides. But in like 40 minutes, that's going to be kind of tough, and slides have like multiple things going on. So I might fly through some points. If you'd like me to slow down and elaborate on anything, just let me know, or obviously feel free to ask questions at the end. So about me, you just heard I'm principal consultant. I lead Aspect Security's automation and integration services group, which is primarily focused on how to use tools effectively and efficiently for scaling application security. We'll talk about why there's a need for that. I've been working at Aspect for 7 years, actually, and this is the second time I presented at LastCon. You can see my Twitter handle and my key interest here. But I wanted to get an understanding of the people in the room and your experiences with static analysis before we go into it. So how many of you use static analysis within your organization? Most? Okay, that's good. And how many of you use commercial tools? Still most. And open source tools? Not too many. Okay. There's value to the open source tools too, so I want to talk about that today. How do you use tests? Is it all manual scanning, manual triage, like full manual process? You have security analysts who just do everything? No? How many are integrated, like automated processes integrated into either development or CI or something? All right, good. That's where I think this should be. We'll talk about that some more. So why do we need tools? You're all probably pretty familiar with this. A lot of conversation about this so far at this conference. Manual security activities have been bottlenecks for development to get applications into production. And that's a problem, right? Because the business is always going to be pushing for features and bug fixes, and security wants to say, wait, don't release that yet. We haven't checked it, or we have checked it, and you have to fix these things before you can elevate to production. But the business always wins, right? In most cases. So you get this kind of broken bottle effect where the business is circumventing security to release their code into production. They make these risk-based decisions where they don't really understand the risk that they're taking on, but there's no time to fix anything anyway. Maybe we'll fix it in the next version. That's the hope. So security has to figure out how to fix this issue, how to either widen that bottleneck or some other scenario where we can have security and development, especially as development gets faster and faster. So in your application security tool belt, there are lots of different options. You probably have at least some of these in your organization. I'm not going to really go into any of the other ones. I'm just going to talk about static analysis. But there are lots of different options, whether they're tools or some of the manual approaches at the bottom. And I'm sure there are other things that aren't listed here. So we're really just going to talk about static analysis and what that is. So it's often called white box testing or clear box testing. It essentially means that you have access to the internals of the application to test, as opposed to black box testing, which dynamic analysis does, right, where you're kind of poking from the outside without knowledge of what's going on inside. There are a couple different ways that it's performed. I'm going to elaborate on each of these as we go through, but there's the typical standard grep, or advanced searching, through your application. That's the easiest to do. There's data flow and control flow analysis. I'll describe what those are. And one of the key benefits and drawbacks to static analysis is that it checks all possible code execution paths within your application by default, usually. You can configure it for less, but typically it's going to check everything. That's great, and it's really bad, and we'll talk about that. And these are just some of the examples of some commercial and open source tools you can use. Find security bugs is open source, PMD, and I think that's it. I don't know if SonarQube is. SonarQube may be, yeah. It's a great tool. So why do security tools or static application security testing tools have such a bad reputation? A lot of the onus, I think, falls on the vendors. The vendors are product companies. They're not generally service companies. So they want you to buy as many licenses for their tools as you can possibly afford. They don't want you to have budget left over for helping you to get those tools set up and used properly within your organization, right? That's the salesperson's prerogative, is how many licenses can I sell you? And that's what usually happens, is they'll sell you a ton of licenses and you'll get the tool. It'll be sold as a silver bullet, right? This is going to solve all of your security problems. It's going to be easy to set up, easy to run, and It's going to solve all your security issues. But that's not really what happens, right? Using these tools out of the box is not really how they're designed. And vendors know that. The salespeople may or may not know that. But the vendors actually know it. And so they shouldn't be selling it to you that way, right? They should be selling you a tool with some professional services to get you off the ground and help you get up and running, or bundle those into the cost of the tool so that they can provide that to you. But they shouldn't be expecting organizations to know how to use these tools effectively and efficiently on their own. And most security tools, or most static application tools, aren't really where they need to be. They're not really where the security industry expects them to be, or at least not at all how they're sold as silver bullets, right? But they're continuing to evolve. They're getting better over time. And we'll talk about the OWASP benchmark project maybe later. You may have heard about it already. But I'm hopeful that that will eventually push some of the vendors and commercial tools to do a little bit of a better job. We'll see. Or some other initiatives may do it. So today, I'm going to answer a couple different questions. Generally, why does static analysis take so long? And why are there so many false positives? I think those are the key issues here that cause people to be frustrated by those tools. We're going to talk about in detail how they work so that you can understand this. I have an example using PMD, which, as I mentioned, is an open source static analysis tool, generally not for security, but we're going to repurpose it for security so you can see how that works. And then I'll talk to you about how we've seen many organizations integrate static analysis into their environments and how I would recommend you do it. So for some background, kind of assumptions going in here. When we're talking about static analysis, at least in this case, we're primarily talking about static analysis of statically typed languages like Java and .NET. We're really not talking about dynamically typed languages like Ruby and Python because static analysis for those languages is much, much more difficult. That's a whole other conversation about why that is. But so you can just think of it in that context. There's not a whole lot of tools available to statically analyze those languages, and the ones that are there, in many cases, are just doing sort of an advanced grep, which you could probably write on your own. There are some good ones, but not many. My bias is totally towards Java. That's really where my background is, so I may use Java terminology for some things, but the process is really the same regardless of the language that you're talking about, as long as it's a statically typed language. And I'll be generalizing how SAST works. I'm not going to talk about specific vendors or specific tools and how they work, mostly because I have no idea, right? It's all proprietary information. So I'm going to generalize this at a high level and say this is generally how SAST works. So this is what the normal process looks like, right? You have source code or byte code that gets fed into some sort of model extraction process. The output of that is one or more intermediate representations of that source code or that byte code. Right? Those intermediate representations have many forms. This is very similar if you're familiar with how compilers work. This is the same process so far that a compiler uses. Pass in some source code, get out these intermediate representations like symbol tables, call graphs, control flow graphs, abstract syntax trees, and proprietary models. So all of the commercial tools are going to use at least some combination of these. Generally, the proprietary models, which may or may not include the other types of models. Right? And then you perform the analysis on those. So the analysis that you do, or that most of the tools are doing, is not actually on source code or byte code. It's on these models that have been generated by the tool. Which means that when you want to create a new support for a new language, what you need to do is create a new parser or tokenizer for that language. Right? How do I understand what this language is and convert it to these models? And create rules for that language to say what's acceptable and not acceptable to know when to generate violations or issues or findings for that particular language. So from a high level, this is generally what the workflow looks like, right? You have compilation normally, because most static analysis tools are starting with source code. You can pass compiled code into many of them, but the process will generally be the same. You start with compilation. That handles your semantic and syntactic checking, right? That's just your normal compilation, making sure that you didn't mess anything up, that you're not referencing variables that were never defined, making sure that the classes you expect to be there actually exist, that all of your dependencies are actually there. right? So the static analysis tools are leveraging existing technology, right? They call like Java C to compile your code so that they don't have to figure out if you're actually missing dependencies or not. If you pass this initial compilation step, then generally the static analysis tools assume that you're good. And they can build those other models. Then the scanner model extraction occurs. So the tools will traverse the output of your byte, will traverse your bytecode and create those different models that we talked about. And then they perform their scan, which is analysis. And the analysis is usually in several phases, and there are various types of it. So there are 3 of them here. There's pattern matching, which is the advanced grep, like I'm looking for the word password in a .properties file. Very easy to do. You don't really need a tool to do it, or a commercial tool to do it. Then there's control flow analysis, which is much more complex. I have a whole other slide about that. But a good example is not closing your database connection in your finally block. Right, that's something that you should generally do to make sure that your database connection is always closed. And then there's data flow analysis, which is looking for bad data that comes in that's then output to a dangerous place. Again, we'll talk more in detail in a minute about that. There are other types of analyzers. These are just a couple other ones that I, just searching around, happened to come across. Right, there's semantic, structural, configuration. What the analyzers actually are isn't as important as just the fact that they exist and knowing that there are multiples. Each one takes time to traverse all of those models. Right, that's one of the reasons that static analysis takes so long. So if we look at a Java workflow here, typically you'll compile your Java files, right? And at this point, you'll find out if there are any dependency issues. Are there any classes that I'm missing that I'm expecting, right? Whether they're from libraries or they're supposed to be internal inside the application, what am I missing here? Then you'll compile your JSPs, and very often here you'll run into issues because JSPs are typically compiled at runtime, and so there's a lot more information available to the container at runtime than there is at compile time. So you may reference variables here in other files that aren't defined at compile time. It can get a little bit tricky, but you'll run into more issues here, potentially. And then framework analysis. And this is, if you talk to any other type of tool vendor, they'll tell you this is the weakness of static analysis because they don't understand frameworks, right? And that's partially true, right? The frameworks like Spring and struts, right? How does a static analysis tool understand what's happening in one of those frameworks? They're all annotation driven and configuration file driven. There's no actual source code for the static analysis tools to look at to be able to trace your code through. Then you get to, and I'll elaborate that on the next slide. So, and then there's the actual scan, which will generally include pattern matching plus some other types of analysis, which results in you getting some results out of the tool. So framework analysis, I took this from an IBM slide. So I didn't recolor it, and I just put it up there because they explained it. This is how AppScan source works. For frameworks, they have an engine that they call the framework handler. They call it the waffle engine. And it knows how to understand certain frameworks. So it can parse the configuration files in this framework handler. So if there's a framework handler for that language, this is old, so there may be support for other frameworks, right? It can understand what the framework is, take in the configuration file, and generate a waffle file, right? Which is the web application flow language. That waffle file is then passed into another translator, which produces the intermediate representations, which are combined with the intermediate representations produced by your Java code to get sort of a full view of your application. And they call any methods that aren't defined in your application but are defined in the frameworks. They call them synthetic methods. And so if you actually look at data flow analysis through your application in AppScan source, you'll see some synthetic methods if you use frameworks, and that means that those methods are being kind of inferred by AppScan source based on its knowledge of that framework. So if your tool supports certain frameworks, this is generally how it'll do it, right? It'll take the knowledge of that framework and convert it to some format, some intermediate format that it can understand and use along with the rest of the intermediate formats generated from the rest of your application.
What about just external libraries?
What about them?
Is that analysis in place?
No. Well, usually not. But I'll talk a little bit more about that. But usually no. External dependencies like libraries are usually not analyzed, but they are handled. So that's different. So I'll talk about that at some point. There's a slide for it. So some of the types of analysis. There's general pattern matching, which obviously you should be familiar with. It's just searching for certain strings. And this comes out of AppScan source. And the reason for that is because AppScan source has a UI that shows this. I didn't want to go hunting through configuration files and databases for other tools to find the pattern matching, mostly because I didn't want to break any rules. But they put it in the UI, so I feel like it's fair game to show it. So these are the regular expressions that AppScan source uses to search your Java. I know you probably can't see it at all. So here's one of them, right? All it's doing is searching for the word password in properties files. And if it finds it, it's gonna show you a finding. So this is not very reliable, right? It's going to find it if you call your variable password, or if your password is password, or if there's a comment that says this is a password. But if you call it something else, it's not going to find it. So it's not super reliable. But it is something. It's a step in the right direction. So one of the other things I wanted to point out is that most tools allow you to create custom rules, whether they're more complex like data flow analysis, control flow analysis rules, or they're just pattern matching rules. This is, again, the user interface in AppScan source to create like a regular expression searching rule. So if there are certain regular expressions that you expect should not be part of your application, you can add them here. Customization is really important in these tools. They're really not designed to be used out of the box. So control flow analysis. So this is an example of a small piece of code here. We can see we're creating an XML reader, and we're going to parse some input, and we have a comment from the developer saying this is to prevent XXE attacks. So what's wrong here? Exactly. You're parsing, and then you're setting the feature. Right? This is backwards. This will not protect you from XXE attacks. This is exactly the type of thing that control flow analysis will find. It's sort of like an order of operations. This needs to happen first, and then this needs to happen. Or this always needs to happen immediately after it, or at some point after it. Whatever. There's different rules, obviously, right? And that's where the database finally, that you should always close your database connection finally. That's the classic example. But right, order of operations searching. Data flow analysis is a little more complex, right? So typically in data flow analysis, there are some terms. There's a source. That's where the data comes from. So in this case, we have request.get parameter, which is obviously not a trusted source, right? It's just coming from the user. And then you have taint. Taint is data coming from an untrusted source. And it always there's a particular card in Cards Against Humanity that anytime I hear that word, I always think of. It's inappropriate, so I'm not going to put it up here, but think about it in your heads and you'll laugh. Yeah. So anyway, so taint. And so taint is just considered basically dirty data, right? It's something that you shouldn't trust. And it gets passed around through all of these method calls. And so anything that taint touches becomes tainted data. So you can see here that we take the taint and we pass it into this new string b. B is now tainted. It's tainted data, right? So that needs to be tracked throughout our application as it moves between different variables. Then you have the sink. The sink is where the data is actually used. That's where you say untrusted data should never be used in this particular position, or this type of untrusted data should never be used in this particular position. So here we're taking data from the user, and we're basically just sending it right back out to the user. That's reflected cross-site scripting, right? I'm jumping ahead a little bit, but so and then all of the intermediary nodes, or all of the nodes, are considered data flow nodes or trace nodes. So is this a vulnerability? You kind of ruined that, but yeah. So so you have untrusted data, you have the taint, and you have the sink. So there are a couple different types of data flow analysis. One of them is called taint analysis. So here we're going to look at each line and how it interacts with the taint. See how it interacts with the taint. So here we see that string A is now tainted, right? Then B is now tainted because it takes in data from A. It's basically a Boolean value on each node of the trace to say it's still dirty or it's not dirty, right? And you go through all the way until you get to E, and E gets put into this print line, which we know is a sink, and so this is a vulnerability. Taint analysis. Call me out if anything doesn't make sense, please. Then there's string analysis. Some tools have this, some don't. It's much more complicated. It's much more resource intensive. It takes a lot longer to do it. So the tools that do have it usually have it disabled by default. But basically, it's able to trace exactly what part of the string is tainted. So I know it's the formatting's a little weird here, but we know that basically B's substring, right, part of B, this specific part of B is now tainted. And then as you go through these other calls, it should be able to tell what part of the string is tainted. And if that part of the string is tainted, then you would end up with a vulnerability. Most tools are not very good at that, though. That's pretty advanced.
But in that case, what is the exact potential?
I mean, well, I mean, it could still be reflected cross-site scripting. If you take something from a user, which is then either concatenated or modified in some way, but the original data, you know, if I pass in 10 characters and then a script tag with, you know, to do something malicious, and then another 10 characters, maybe the first and last 10 characters will be modified by this, but my original, like my attack, is still going to come out. Yes. So yeah. So. Right. Well, so this is not a perfect example in that case because you're right, because we don't know actually where this response is going. It's going, in this case it is, I know that it's an HTTP response because I wrote it, but you can't see that. But even still, you don't know where it's going to be in the page or anything like that, right? So it's not context aware in this case. They will in some cases, because, so this is a very simple example, but right, your applications, your source is probably going to start in like your JSP. And your sink might end up in your JSP, right? And so all of the code along that gets called along the way will be traced if it can do it. Yeah. And then there's lost sinks, and this is kind of what you were talking about dependencies. Intermediate representations are not created for external dependencies. They're only created for your code that's compiled because it would take forever, not really forever. It would just take a long time to produce the intermediate representations for all of your dependencies, right? Most enterprise applications probably have several hundred libraries. And so to go through all of those and produce the intermediate representations that connect to your source code's intermediate representations would take a very, very long time. And then to go through it all would take a very, very long time. So it's mostly from performance reasons. Though I was told once that there may be actually like issues with analyzing third-party dependencies from a legal standpoint without their permission. So I don't know how much that plays in. But it's not done. So anyway, so if you get to an external dependency and you don't have a rule that tells the tool what happens in that external dependency, that's how you end up with a lost sink, right? So data flow goes to that method, and the tool's like, I don't know what this method does. I see you pass something in. I see you have a return value, but I don't know if that return value is messed up because what you passed in was messed up, right? By messed up, I mean tainted, right? So most tools have a way to create rules to determine, to tell the tool what should happen if data flows through one of these external methods, right? The tool vendors have huge libraries of these for like many, many open source tools. These rules are already defined, which is why you don't end up with lost sinks all over the place. You probably end up with a lot of them because anytime you reference a library for one of your other applications or one of your other services within your organization, right? If you use a jar file, you import that jar, the tool doesn't know anything about it. So you end up with these lost sinks, and you have to write rules to tell the tool that if I pass something malicious in here, if I pass tainted data in, then I get tainted data out. Or I pass tainted data in, and I get something clean out. And then if you write those rules, then the tool will know, and it will be able to follow, and it will say, all right, well, then on this next line, this sink is or is not a vulnerability because it knows it can follow the data flow all the way through. Does that make sense? So this is the value that like professional services, or if your team can learn more about how these tools work, you can write these rules. But this is a perfect example why these tools should not be used out of the box. Some of the commercial tools are really good about telling you about lost sinks. and a lot of them just swallow them and pretend they're not there. So it really depends on the tool you're using about whether or not you'd even see this somewhere in the user interface that there are lost things. You might just have to know these are the libraries we're using that we wrote and we're importing. We need to write rules for them. That's where like that sort of that expert level for static analysis can come in and tell you these are the rules you need to write and this is what they should be. And they'll need to work with your development teams because they'll need to know this information, right? Like I don't know about your external method calls if I don't know what they do. So unless you give me the source code or someone to talk to about it, I can't write rules. So again, one of the positives about static analysis and one of the negatives, everything is checked, right? Every potential data flow in your application is checked, almost. There are some changes for performance reasons, right? Because every conditional statement in your application generates totally different trees that your data and control flow can go through. And so the bigger your application, the more conditional statements you have in your application, and other things like inheritance. They all add challenges to the static analysis tools. Make it take more time, right? So first of all, SAST doesn't know what will happen at runtime. In this case, right, is input going to be foo or foo2? I don't know, so I'm going to have to check both of these paths fully. And these paths may call another 20 different methods before something returned, before something happens. That means I'm checking actually 40 methods, right? Plus all the stuff before and after. So it ends up being a lot. So the benefit of that is none of your other tools are doing it, right? Dynamic analysis is only checking when you send a request, it's only checking what's actually executed. And interactive analysis also, right? So the benefit here is that you're going to find things that are edge cases. You're going to find things.
Check.
Is this on? Yeah. So I feel like I should sing or something. So the benefit of this is that you're going to check all of your edge cases, all the things that you think this could never happen in my application. I'm not saying static analysis is good at finding like malicious code, but it's more likely to find it than your other methods because it's going to check things that you're not typically executing during QA or during your other security tests. So there is value here. But that's also part of the reason you'll get back a ton of false positives, because it's checking everything. Even code execution paths that will never actually happen. Yeah.
Switch back.
Thanks. Sorry. So now back to those questions that I asked earlier. Why does static analysis take so long? It's a long process, right? The whole application is compiled first. So it's always going to take minimally as long as it takes for you to compile your application, which for larger applications can be a while. Then the whole code base has to be translated into one or more intermediate formats, which is a long process. And then it's a multi-step process to analyze it. You do all of your regular expression checking, control flow analysis, data flow analysis, and you're checking every path with all of these types of analysis. Then you have to produce your findings report, which, when you find 50,000 findings, can take a while to produce that report. So it takes a while, but there are some positives for it. But I'm hoping that if you understand why it takes so long, maybe you'll be a little bit more patient with it. I don't know. And then why does it produce so many false positives? Again, every potential flow is checked, which can be, you're talking about probably hundreds of thousands or millions of potential data flows within your application that are all checked within, it takes a couple hours. Because they don't know which logic will be executed at runtime. They don't know which sources your business trusts, right? So should I trust data that comes from your database? Your database may be populated by you, right? And maybe or maybe I don't trust you to populate your database. It could be populated by another application or service, which may or may not have the necessary controls to make sure that data that goes in is not malicious. It could come from configuration files. It could come from users. I don't know. So most static analysis tools will by default not trust any sources like databases and configuration files. Yeah.
Can you allow me to say
Most.
findings filter by time?
So the triage that's the triage process after the scans run. You can definitely do that. For some tools, you can also specify what sources should and should not be trusted. But the triage process is really important. I think we'll talk about that a little bit also. But yes, you should definitely be doing either manual or automated triage, and that could definitely be part of it if there are certain sources you want to trust and others that you don't. And that's, well, and yeah, okay, so that's exactly the last point. Most SAST tools are architected to have some sort of post-processing, which is the triage process. After the scan is run, the results are not designed to be delivered to developers. I think a lot of static analysis vendors for a couple of years were like, oh, we can give these tools to developers. They wrote IDE plugins for their developers. That's a failed experiment in my experience. Developers should generally not be running these in their IDEs because they're going to get too many false positives that they're not going to know how to handle, and they're going to be spending too much time trying to figure out which ones they should and should not resolve instead of writing secure code. I mean, there are better ways to spend their time. So I would not recommend the commercial tools, at least, is really what I'm talking about. If you use the open source tools, they're usually not as error prone, or you can tweak them a little bit more, and they're faster because they're not looking for as much. Usually they don't have the data flow and control flow analysis. So yes, but you should definitely be doing some post-processing. So there's interprocedural and intraprocedural analysis. So they're big words, but it's pretty simple. Interprocedural just means that you're looking at the entire application, the whole system, right? So that's what your commercial tools are going to do. You're going to pass in your entire code base. The entire thing is going to get scanned, and it's going to be able to trace your data flow from one entry point through multiple classes and frameworks to its exit point. Whereas intraprocedural analysis is usually just checking a file or a function or something much smaller. So most of the commercial tools, probably all of them, are interprocedural tools. And most of the open source tools, though not all of them, are intraprocedural, meaning you're looking at one file at a time or one function at a time.
With the rise of microservices and stuff, you're going to lose a lot of service. So now you're going to have instead of one monolithic app, which you can do full status analysis on.
Right.
How do you correlate all those?
So it's an interesting question. So the question is, if you have, I mean, even before microservices, right, you can have applications that have, right, SOA, but they're like multiple components for an application. Figuring out how to scan that application, what your strategy is, it's a thought process, right? Do I scan this whole thing at once, right? Then I get all these findings and I have to split them up and give them to the right groups to resolve issues. Or can I scan each one individually and correlate somehow? But the problem is, like you said, then each one becomes a dependency of the other. And remember, we're not building those intermediate representations for dependencies, which means that you need to write custom rules to say that the output from this service is clean or is not clean, et cetera. And you need to do that for all of your services. So it's a toss-up. It's a conversation. But no matter what you do, I'm not trying to sell static analysis to anyone here. There are clear benefits for it for me, and there are clear drawbacks. And I'm going to drill this in later, but this is only a part of your application security program. This is only one of the tools in your tool belt that you should be using. You're not going to get full coverage with it. So now we're going to talk about PMD. Has anyone used PMD? Yeah? A little bit? Okay. So what is PMD? This comes from their website. You can see basically by the description, it's used for unused variables, empty catch blocks, unnecessary object creation. It's not a security testing tool. And it is an open source tool. I was reading the source code for it the other day, actually. It's pretty interesting if you want to learn how static analysis works, which I didn't realize how I didn't know before this. So anyway, but the reason I chose it, even though it's not a security tool, is that's exactly the point. Not every tool in your security tool belt has to be used, has to be a security-focused tool. There's a place for these tools elsewhere, right? Like you may be using PMD in your CI environment anyway. Your developers may be running PMD tests already in their IDE. So why not just write a couple security tests for it, and then you're getting that security coverage for free, right? They're already being run. There's no overhead, and the only cost is writing the rules. So we're going to walk through writing a rule. So I want to just give a quick shout out. This is one of our competitors, but Gotham Digital Sciences. This is the only open source group of PMD rules that I could find on the internet at all for security. So I haven't used them, but I did go through their code, and it looks pretty good. So I just wanted to give them a shout out because I think they're doing things right. Even though you should still, come to Aspect, not that. So we're going to write a PMD rule. I was actually going to write it with you, like on my screen through Eclipse, but I thought it would be too slow and you'd probably get really bored. So instead of that, I'm just going to kind of walk through the creation of it. So some assumptions here. Let's say we work for an organization. All of our applications use Spring. Right? This is a simplified example. And we have a policy that says that, and so in Spring, when you want to map a particular function to a particular endpoint, web endpoint like / whatever, right? You use this request mapping annotation. Functions lacking the method variable as part of this annotation are available to all HTTP methods, right? So post and get, delete, put, and we want to limit that. So we want to say that only for our organization, we have a policy that you have to use get and or post. You have to use one of those two, nothing else, and you have to specify at least one of them, right? I don't know how applicable that rule is to anyone if you use other methods, but it's an example. So step one, we have to write our test case. And this is not just because I like test-driven development, but also this is just how PMD works. You have to write a test case in order to generate what you need to write the actual stuff. So I came up with 5 test cases for this. There's 2 more on the next slide. But generally, you have a correct method, right? This is what we want our developers to do. And you could see method request method post is in there. This is incorrect because we're specifying delete. This has nothing. We don't want that. And I was like, well, what if they specify multiple methods? This is also correct with multiple, and this is incorrect with multiple, right? Because we have delete here. So first I wrote those. And then you have to generate and analyze the abstract syntax tree that PMD can produce. And there's a utility that comes with PMD called Designer that will show you how to do that. And that's what this next slide is. Basically, you have to reverse engineer what you wrote. So this is what an abstract syntax tree looks like coming out of PMD. General format is the same for abstract syntax trees, but the variable, like the names, may be different, right? PMD calls this a class or interface body. It could be called, I don't know, foo, somewhere else, right? That's not standardized, the name. I'm definitely going over my time. So if I don't get through it, let me know. So that's what we're looking for. So here we're looking for this request mapping variable as a name because you see it's specified as a name. And I can see it's a child of normal annotation. So I passed my code into this designer, and this is what it spit out, in case that was not clear. So it's a normal annotation. Then under normal annotation, I see method, right? Method is what I'm looking for. So it's which is a type of member value pair. And this is the value we're looking for the method to be, right? Which is a type of primary prefix. I don't know if that was too fast or too complicated, but now we're going to write the rule, so hopefully it'll make more sense. So the first thing we have to do is extend this abstract Java rule, which is a PMD type. We use this visit method. You can pass in any type of object, any type of PMD abstract syntax tree object in here. So this is saying basically anytime PMD creates an abstract syntax tree and then I run analyze on it and I see a normal annotation, call this method, right? So you could do this for again, class or interface body, and then for every class, you would go through this analysis. We're only going to do it for annotations, this type of annotation. We're going to look at the node that's passed in. We're going to get the first child. That's a name type, because we have the name type here, first child of normal annotation. We get the get image, which is basically get attribute request mapping. So if the name of the first child of the normal annotation is request mapping, then we're going to run this code. We're going to find any child nodes that are of member value pair, because we see that here. I'm speeding up now, so we could talk later if you have questions. And then we're going to get the attribute, basically, if it's a method, right? Because we don't care if you pass some other parameter type into your request mapping. We only want to look at the methods. And then if the primary prefix, we're using XPath here to search. If the primary prefix is there, if it's request method.post or get, if it's not that, then we're going to add a violation. So this is saying if it's anything besides post or get, we're going to add a violation. So PMD is going to throw an error, right? This is what the final rule looks like. Now I'm going real fast, but it's pretty short. This took me about maybe 25, 30 minutes to write, which is not too bad. But this is a simple rule. I'm out of time, so feel free to go if you want to. So that's what it looks like. The report finds the issues. That's the important part. You can use XPath if you want. This is what it looks like. As an example, instead of writing it in Java, where does SAST fit in? I have some SAST tips here that I'm happy to talk about, but I don't know if the next speaker is going to want to kick me out. But key takeaways are SAST should be only a part of your AppSec program. You need vulnerability management and remediation. Don't try to scale static analysis if you don't have a way to handle the issues that come out of it, and you don't have a way for developers to fix it. That means developer education, like training and support for them when they come to you and say, I don't know how to resolve this issue, and you have to say to them, well, you're going to have to redesign your entire architecture to handle that, right? SAST belongs in CI. I don't think developers should be using it, not the commercial tools. They could be running PMD and SonarQube and other things like that, but they shouldn't be running the commercial tools in their development environments. They're going to get way too much noise. It's going to slow them down. Developers should never, ever, ever see false positives. So you either need like very strict filtering after the scan, or you need people to manually look at the results and make sure that they don't get false positives, or you're wasting your developers' time. And then lastly, alternatives. You don't have to use the vendor-supplied consoles. Each static analysis tool has a complementary console where all the results can be. But there are alternatives. You can write things to take that output and put it into SonarQube or ThreadFix or Archer, whatever your GRC tools are, something else. Whatever's the best way for you to look at it. You don't have to set up 55 dashboards across your organization. And then always continue to improve your static analysis. So this is the way it's supposed to work. You scan all of your applications, but your most critical applications you're also doing other security activities on, like full scans, manual reviews, threat models, whatever. All that information should get passed back into the scan somehow, like by creating those extra rules and filters to get better coverage, reduce false positives. That will overall enhance your scans, provide remediation guidance that's going to increase your coverage too. Because overall, you want to reduce your risk. That's my last slide. So, okay.